So in this video, we're going to talk about the quotient rule. Okay, so at the top of your page 50, you have either the word product or quotient highlighted. If yours is highlighted on the quotient rule, this is the video you should be watching. If yours says product, you should be watching the other video. Okay, so the target for today is students will learn and apply the quotient rule to complex functions to find the derivative of a function so that they can calculate the instantaneous rate of change. Okay, always keep in mind that anytime we're taking the derivative, remember we're finding that unique slope formula to the function that we're deriving. And of course, that's going to be used to find that idea of instantaneous rate of change at a single moment, at one point. Okay, so the quotient rule allows us to start to take derivatives of quotient values that we can't simplify. So for instance, like this first example, this over x squared minus 1. We can't simplify that, we can't break it down, we can't pull it up as a unit, so we don't have a choice other than go to this idea of the quotient rule. And what the quotient rule says is if we take the derivative of a quotient, so a function over a function, a rational, is given by the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator, all divided by the denominator squared. So simply derivative of the top times the bottom minus derivative of the bottom times the top over the bottom squared. So here's the thing to always keep in mind. Anytime we're doing this, two derivatives should never go together. Okay? And that's going to be true for your product rule as well. Okay, so for example, if I have y equals 5x plus 2 over x squared minus 1, I can take the derivative using my quotient rule. Okay. And that quotient rule says to take that derivative, so I'm going to get dy dx. It's going to be equal to the derivative of the top, so this being the top right there, derivative of top, which is just 5, times the bottom, minus the derivative of the bottom, so that's the bottom right there, so 2x times the top, all over the bottom squared. Okay, so that's kind of the essence of the quotient rule. After the quotient rule is done, it's now just a matter of algebra and just simplifying and combining like terms. So I'm going to distribute, so 5x squared minus 5. And then here, when you distribute that negative, this is where if you're going to make some algebraic mistake, it's common to forget to distribute that negative out to both terms. So watch out for that. So negative 2x times 5x gives us negative 10x squared. And negative 2x times a positive 2 gives us negative 4x. All over the bottom squared. Now don't worry about distributing out the denominator, just kind of leave it in square form. That's in factored form. We like that form because that allows us to solve. And it's easier to plug into whether than we expand it. So we're never really going to expand our denominator here. I'm going to get a little bit more room just to combine my like terms really quickly. Now we get the 5x squared and that negative 10x squared give us negative 5x squared. Then we have that negative 4x there and that negative 5. And then all over, again, just bring down the denominator. Okay, and we're done. That's it. That's the derivative. Don't worry about factoring it. Remember, the whole point of these is to plug in. If we need to factor it, then we'll go ahead and do that later. But there you go. There is the derivative. Okay. So if we go to B, same thing. There's nothing that we can do to simplify it to bring our denominator up because we have multiple terms. So we're going to have to be forced to use this idea of the quotient rule. Okay, where e to the x, that's going to be our top, and then of course x squared minus 4 is our bottom. So our derivative, quotient rule says first to take the derivative of the top. We learned that the derivative of e to the x was in fact e to the x. So the derivative of the top times the bottom minus derivative of the bottom, so that's going to give us a 2x times the top. And I'm really using my parentheses here so that I don't miss any terms and I don't miss distribution at all. Okay, and then over the bottom squared. Then after this, I'm just going to simplify it. So e to the x times x squared minus 4 e to the x minus 2x e to the x. And then again, I'm going to leave my denominator as is. Okay. And really, if we look at this, there's not much that we can actually simplify down. So we're just going to leave it like that. There's our answer. We're going to move on to the next derivative. Okay. So the last example on here says to find the equation of the tangent line to y equals, and it gives us an exponential like the previous one, and then it gives us the point. Remember, to find the equation of the tangent line, we're doing 4 things. We're finding the y value, we're taking the derivative, we're plugging into the derivative to get the slope, and then of course plugging into the tangent line itself. So this one gives us our y value, so our first term is already done. So our second step is to in fact take the derivative. So our second step, that's what we're on, is that dy dx. Okay, so if we take the derivative of the top, e to the x gives us e to the x times the bottom minus derivative of the bottom times the top all over the bottom squared. Okay. Now we can take our time simplifying this, but remember the whole point of this is to actually plug in. So if I have the derivative here and I'm going to plug in at that point of x equals 1, I'm just going to go straight to the plug-in from here. So my third step, okay, is to take the derivative, and this is some notation for you, and this says to take the derivative and evaluate, we call that an evaluation bar, at x equals 1. Okay, it's kind of like when I say f prime of 1, same thing in y notation, and that's what it looks like. Okay. So I'm just going to plug in. So we get e to the first times 1 plus 1 squared minus 2 times 1 times e to the first. And then of course 1 plus 1 squared, sorry, that's a plus squared. Okay, and then we're just going to simplify this. So 1 plus 1 squared gives us 2, so we have 2e for that first term minus, and look at that, 2e as well. And then of course I always want to check to make sure it's not 0. So that would actually give us 2 in the parentheses, and then 2 squared will give us 4, which that means our slope is in fact 0 here. Remember, it's okay to have a 0 slope, and what that means is we have a horizontal tangent line at that point on that function. So the last thing I want to do is write the equation of my line. So y equals my y value there, which happens to be e over 2, plus my slope times x minus my x value of 1. And there's the equation of my tangent line. So if you have any questions, that's the end. We'll do the next page in class together tomorrow. But if you have any questions, just come see me.